In this video, we're going to be going through HTTP in detail as part of the TryHackMe walkthrough series that we're doing for the pre-security path. So what is HTTP? There is a 90% chance, that is a fake statistic, that you watching this video right now know exactly what HTTP is. But in case you have never interacted with the internet yet, there is a percentage chance that that has happened. HTTP stands for Hypertext Transfer Protocol. Now you want to be familiar with two different types of HTTP. There is HTTP, which is just that, it runs on port 80, and then there's HTTPS, which is HTTP, but the S stands for secure, and it is the encrypted, more secure version of HTTP, and that runs on port 443. Now there are several practical labs here along this walkthrough. You can do that on your own to be able to grab the flag for yourself. It is great practice and great visual representation of what's going on. But right now, let's jump into what exactly a URL is, which stands for Uniform Resource Locator. And here you have a nice graphic that breaks down URLs in depth. For instance, you have a scheme, you have the user, the host domain, the port, path, the query string, fragment. If you're brand new, this might seem a little overwhelming, but don't worry, it's fine. We're gonna look at this. Basically, the scheme shows the kind of protocol you're gonna use. So for instance, it could be HTTP, it could be HTTPS. You could use FTP for file transfer protocol. There's several other methods that you can use as well. The user, I feel like I haven't really seen this very often, seeing the username and password shown right there in the URL. So I think that this is kind of an older scheme. Maybe I'm wrong, let me know in the comments. But it could be theoretically in the name, and it would be username, password at, and then the actual domain itself, tryhackme.com. Now you'll see a colon and a port, and that is basically specifying to the destination that you are wanting to access via the specified port. So because we are using the scheme of HTTP, its default port is running on port 80. So logically, we will be reaching out to port 80. Now a path, we are trying to go to the path of view room. So we are looking for a room with an ID of 1. And that includes a fragment of task 3. So whenever you make a request using HTTP, basically you will specify your method, and that could be get or post. There's several other methods. We'll talk about all of that here in just a moment. Slash for the page, and then you'll do slash if you're doing the root page, or you can actually specify the page itself that you want to grab or whatever. Do any kind of request to. And then you will specify your HTTP protocol version. And then here we have down below an example of an HTTP request. You can catch all of this even in Burp Suite. If you are intercepting, or even if you're just passively watching web requests being performed, you can actually view all of this being done in Burp Suite. In fact, if you are intercepting HTTP records, then that traffic will be unencrypted. So not only can you view the traffic happening in Burp Suite, you can actually make different changes to it, and that can actually impact the user or the website, because now you are manipulating communication. That is called a man-in-the-middle attack. It's illegal if you don't have permission, so get permission or do it in home lab to yourself. Now, we were just talking about the different types of HTTP methods. So like, what are we talking about here? Well, these are just 4. There are several others out there, but the main ones that you want to be familiar with are get and post requests. Get requests basically are saying, hey server, get me this, and then post requests are saying, hey, I'm posting this to you. A put request updates information, and a delete request deletes information. But either one of those, you may see those much less often than you see get and post requests. Now on to the fun conversation of HTTP status codes. Who loves these? These are the best. Well, here we have a lot of the standard status codes, including we have basically the ranges. So 100 to 199 is informational or response. 200 to 299, it means it's some form of a success. For instance, 200 is okay. 300 to 399 is for redirection. 400 to 499 is client errors, and 500 to 599 is server errors. And if you're not familiar with what that means, you basically consider yourself to be the client and the server that you are connecting to be the server. So 400 is basically the web server saying, hey, it's your fault. 500 is saying, hey, it's my fault. And then of course, below that, we have the common HTTP status code. You'll probably encounter these at some point. In fact, error 404, page not found, that's it's got to be a meme on the internet at some point. So these will be good to be able to familiarize yourself with. However, I feel like, at least in my experience, whenever I see one of these codes, it will blast the message. So you won't just get 401. You might in some cases get that. You might have to do some Googling if you forgot, but it might also just say 401 not authorized right below that. So either either way, keep these in mind. Now let's go to HTTP headers, because this is just so much fun. These are basically sent from the client, basically you, to the server. They'll basically show the host, so basically who you are. They will show the user agent, so basically your browser, the content length, so how much data that you are expecting, and accept encoding, whether or not you want to accept encoding, and a cookie. We will talk about that in the next section, so keep that in mind. Common response headers, set cookie, so that will actually set the cookie for you if that hasn't been set yet. Cache control, which will store the content. Content type will tell you basically, are you looking at HTML, CSS, a combination of these, and then content encoding. So those are some things to keep in mind. Now, mind you, all this is being done automatically on the back end. You're not manually doing this. Obviously, your browser and your computer are doing that with the server, but it's helpful, especially if you're wanting to get into cybersecurity or networking or what have you, to know about these things. Now, what are cookies? Nom nom nom. Cookies basically are unique to your session. They may include authentication data, so if you log into a service online, then your unique ID might be stored in some sort of an obfuscated form, hopefully in the cookie itself, and that basically lets the server know that you are you and you are coming from a specific session and you are authenticated. Your cookie will be unique to you and stored. So let's say you log into a website, then you leave, and then you come back the next day, you'll have the cookie and you'll be able to show the website, hey, it's me again, Hank the Cow Dog. And then you'll be able to continue to do whatever you're doing and it will remember you. Why does this matter? Because attackers might try to steal your cookies. No, not my cookies. And they will try to use that to imitate basically you to the web server and perform tasks as if they were you and steal data potentially. So protect your cookies with your life. If you want proof that you have cookies, check your browser. It has them somewhere. Now, to finish this room up, there's a making a request practical. There's several flags on here for you to get. Go ahead and jump through it. Super duper easy. You're gonna have a blast. It's just basically running through the different types of requests you can make to a web server. So with that, the next room will be how websites work. You can check that out on the top video. If that's not out yet, or you haven't seen some of the other walkthroughs on this playlist, check out the bottom playlist. There's a lot more where this came from. Always like and subscribe because I crave attention. Just please, I'm locked away. Anyway, see you later.